Let's move on to the next question. The diagram shows the curve y equals to this, root of 3x plus 1. Now, as we have seen many times before, the first thing we can do here is to rewrite the equation. This is also equal to 3x plus 1 power half, right? That's the first step. Now, we also know that we have a point P and Q, they are both on the curve. These are the given values that we might use sometime later. Now, the shaded region is bounded by the curve, okay, the y-axis and the line y equal to 2. As you can see here, we have a region. It is bounded by the y-axis, the line, and this one. Now this is the equation of, let me kind of complete this. This is the line that we have here, which is y equal to 2. Great to know. Okay, so part 1, we have to find the area of the shaded region. Okay, so how can you find this area? So we have to observe and think step by step. So to find this area right here, we can first find the whole area, right? Let's do that first. Now, how can you find the whole area? So by observation, you can see we have a rectangle for the whole thing. So number 1 is area of a rectangle. How do you find this? It is length times width. Length is 1 times width, it is 2. Because this is value of 2 here, 2, right? So the whole area is just 2 units square. That's the first part. Now to find only this one, we have to remove this part of the area. Now to remove this part, it is what it is, as you can see, it is area and the graph between the limits of 0, 1. So number 2, that will be integration between 1 and 0, sorry. And then that will be the curve that we have been given by the question. So we want to remove this part to find the area that we need. So one by one, this is simple integration. You first have to increase the power by 1. That will be 3 over 2. Divide by the same power. And then divide by d by dx of the value inside, that should be 3. Simplify, you will have what? So 2 will go up, that will be 2 over 9, so 3 times 3 is 9, times 3x plus 1, 3 over 2, 1 and 0. So let's continue on top, some space over here. You can see 2 over 9 is only a multiple. We can just take this outside, that will be 2 over 9. On the inside we have, first we put the value of 1, that will be 4 power 3 over 2. And then we put the value of 0, that should be minus 1 3 over 2. Let's see what happens. 4 power 3 over 2 is 1.5, that should be 8. 8 minus 1, that should be 7. So 2 over 9 times 7, that should be 5 over 9. Now this is the area of this part that we do not need, right? Now to find the area that we need, we take the whole thing, which is 2, minus the one that we don't need. Let's see what do we get. 2 minus answer should be 4 over 9 units square. So this is the answer for question part 1. Now for question part 2, we have to find the volume obtained when the shaded region is rotated through 360 about the x-axis. Now usually when we have a rotation about the x-axis, we have to know which formula we are going to use. So about the x-axis, we know we have to use volume is equal to this, and of course integration, and that have to be y square with respect to dx. When we have about x-axis, we have to make y become square. But again, this is usually what we have to use. But now we have to understand the context we have over here, because here we are trying to find this volume when this area is rotated about the x-axis. There's 2 parts we kind of have to think about here, because it is not that direct in this case. So at first we want to, because we understand the area here was the area of the whole thing minus the area below the curve. Now, volume again is the same logic. It's the volume of the whole thing minus the volume of the inside part. So how would you find the volume of the whole thing? So if you think about this, here we have the x-axis. At first, we have to look at this line. Now, when you rotate this line about the x-axis, for example, you have x here, rotate about the x-axis. If you think about this, it will give you what? It will give you a shape like this, right? So please use your imagination for this question. Well, let's see. Let me draw something here. So this is the x-axis, for example, right? And I'll rotate the line around the x-axis. For example, you will have a shape something like this. If that makes sense. When you rotate this one around the x-axis. Now, this is the radius, the value is 2, radius is 2, and the height is just 1. So what is the volume of this whole thing? It is the volume of a cylinder. So pretty easy. Volume of the whole thing is pi r square h, which is pi. R square is 4 times 1, that is h is 1, right? It is the height, it is 1, as we can see here. That will be 4 pi for the value of the volume of the whole cylinder. Now, we don't want the volume that is below the curve that is rotated about this object. So we have to minus that volume. So that volume will be found pretty easily by using your formula. So unwanted volume that will be, limits is obviously 1, 0. Pi is pi. Now what is y square? Y is this value square. That will cancel out. You will have 3 x plus 1 respect to dx. Now we can take this out. It's only a multiple. You will have 1, 0, 3x plus 1 by dx. Now simplify. Pi is pi. That will be 3x square over 2 plus x. 1, 0. Pi is pi. That will be 3 over 2 plus 1 minus 0. So let's see what we get. Here, pi is pi again. So 3 over 2 plus 1, that should be 2.5. So the unwanted volume is 2.5 pi units cube. Okay, so what is the volume that we need actually? So pretty easy. It is the whole thing, the whole volume minus the unwanted volume to find the one that we actually need. So the whole thing was found to be 4 pi minus 2.5 pi. That will be what? 1.5 pi. Let's check. 4 minus 2.5 is 1.5 times pi should be 4.71 units cube for volume. So correct your 3SF. That'll be part 2 of the question. Again, this one requires somewhat of your imagination. You have kind of think of this. We cannot find the volume directly, obviously not in this case. We have to kind of think what can we do first to find that, right? That will be part 1 of the question. Let's move on to part 3. Now tangents are drawn to the curve at the points P and Q. Okay, so point P is given to you here, point Q is given to you over here. Now, we are trying to find the acute angle in degrees correct to 1 decimal place between the two tangents. Okay, so this one is not too bad. It is pretty easy actually. But I don't know if that is still in your syllabus, so please do check and let me know if that is still in your syllabus, but it is pretty easy. Let's move ahead with the question. Now, to find the angle between two tangents, we have to find the slope of the tangent, which is simply the gradient of the tangent. Now we know to find the gradient of tangent, we have to find what? dy by dx. So y was given to you by 3x plus 1 power half. From here, dy by dx will be what? Half 3x plus 1. That will be obviously minus 1 minus half multiplied by 3. That should be 3 over 2 3x plus 1 power minus half. That should be 3 over 2 3x plus 1 power half. That is dy by dx. Now, we want to find the slope of the tangent at the points P and Q. Now, this is the x value and the y value, and the x value here as well. Y, x, x. Now, we have to find the slope. We have to use the x value. So, at the point P, we know the x value is given to you by 0. Replace back in here, you will have 3 over 2 times 1. That will be 1.5. That's the slope of this one. Now, at the point Q, where the x value is 1, you will have 3 over 2, 4. So 3 times 1 is 3, plus 1 is 4, power half is just 2. That will be 3 over 4, and that should be 0.75. So now we have the slope of both tangent. We can find the angle in between pretty easily. So again, the angle at first will be what? Modulus of tan inverse of one of them, let's say 1.5, minus tan inverse of the other one. So tan inverse of 1.5 minus tan inverse of 0.75. That is 19.4 degrees as your answer. But now sometimes it may give you a value which is more than 90. If that happens, you can just take 180 minus the angle to find the acute angle in between. In this case, we have something less than 90. It is acute already. So that will be your answer for the acute angle right here for the question. But now, as I explained, sometimes you may have an angle which is more than 90. If that's the case, and if they are asking you for something acute, you just take 180 minus the whole thing. In this case, it is just perfect, and that will be your answer for question part 3 in finding the angle between two lines, in this case two tangents.